Hello there, Mr. Sutton here, bringing you the IM3 8-3 Extra Practice Number 2 solutions on theoretical probability. For this problem, from a deck of 52 cards, we want the probability of drawing red cards 8 through 10. So our total possible outcomes are 52 for the 52 cards. And how many red 8 through 10 cards are there? Well, there's two red suits, the hearts and the diamonds. So we have the 8, 9, and 10 of hearts and the 8, 9, and 10 of diamonds. That's 6 different cards. And 6 over 52 reduces to 3 over 26. On this one, we want the probability of drawing a spade 8 through 9 out of 52 cards. So our total possibilities are 52 for our denominator down there. And spade 8 or 9, well, there's just two cards here, and they said exactly which ones they are, the 8 of spades and the 9 of spades. So that's wanted outcomes of 2, and this reduces to 1 over 26. For this one, we want the probability of drawing an ace of spades out of a deck of 52. Total possible outcomes is our whole deck, 52 cards, and there's only one ace of spades in that deck. So 1 is our desired outcomes, and then 1 over 52, can't reduce that. For this problem, we want the probability of drawing a face card from a deck of 52 cards. Total possible outcomes is the whole deck of 52. And the desired outcomes, well, face cards are just the jacks, the kings, and the queens. So there's 3 face cards for each suit, and there's 4 suits. We have the diamonds, the hearts, the spades, and the clubs. So 4 times 3 gives us a total of 12 face cards overall. And then we can reduce 12 over 52. I can think we can reduce those by 4s, so that's going to be 3 over 13. On this one, we have a single, implicitly, I guess, they never spelled it out, but it's a 6-sided die. We want the probability of rolling a multiple of 5 on there. Well, our total outcomes, possible outcomes, is 6, the numbers 1 through 6. And multiples of 5 between 1 and 6, well, there's only one multiple of 5, it's 5. So that would be a 1 out of 6. On this one, we want the probability of rolling a multiple of 3 on a single die. So we've got 6 total possible outcomes, and from the numbers 1 to 6, multiples of 3, well, we have 3 and we have 6. So that's 2 outcomes that we actually want, so 2 up here. And then we can reduce this to 1 over 3. For this one, we want the probability of rolling factors of 3 on a single die from 1 to 6. So total possible outcomes is 6 for the 6 sides. Factors of 3, 3 is a prime number, so its only factors are 1 and itself. That's 2 factors overall. And we can reduce this then to 1 over 3. For this one, we want the probability of rolling factors of 4 on a single die from 1 to 6. So our total possible outcomes, we have 6 different numbers that we could end up getting. And how many of them are factors of 4? Well, we've got 1 and 4, so that's 2. And 2 is also a factor of 4, so that's 3 total. And then the other possibilities, 3, 5, and 6, none of those are factors of 4. So 3 out of 6 then, which reduces to 1 out of 2. For this problem, we have a spinner, and if you count it up, there's 11 spaces on here. We want the probability that our spinner does not land on 1 or 4. Okay, so our total outcomes are 11. That's our denominator, so we're going to have something over 11. And let's just count the things that are not 1 or 4. So here's one thing that's not a 1 or a 4, 2. So there's 1, 2, 3, 4. 4 things that are not 1 or 4, so that's a 4 out of 11 chance. For this problem, we want the probability on this spinner of spinning a 3. So total possible outcomes, there's 11 spaces. And then for 3s, how many 3s are there? Well, here's a 3, and it looks like that's the only 3, so that's 1 out of 11. On this one, given this spinner here, we want to know if we have an equal chance of landing on either A or B. So that means we actually have to find the probabilities of A and B and then compare them. Let's do probability of A. Now, in general, there's 8 spaces, so that's your total sample size here, your total possible outcomes. And then the desired outcomes, if you're looking for A's, we have 1, 2 spaces that have an A on them, so that's 2 out of 8, which reduces to 1 out of 4. You always want to reduce it when you're comparing especially. And then our probability of B, it's going to again be something over 8 because there was 8 spaces. Now how many B's are on here? Well, here's 1, and it looks like that's the only one. So 1 out of 8. And since 1/4 does not equal 1/8, you do not have an equal chance of landing on either A or B, so that's a no. For this one, we want the probability with this spinner of not landing on A or B. So there's a total possible outcomes of 8 for the 8 spaces on here. And how many of them are not A or B? Well, it might be easier just to figure out the ones that are A or B and then subtract that from 8. So here's an A, a B, another A, so that's 3 things that are A or B. Subtract from 8, that means there are 5 things that are not A or B, so 5 out of 8.